Hey everybody, I want to spend a short period of time today talking about two concepts that we left off with. One of them would be energy transformation, and the other is energy transfer. Now, we've gone over energy as a whole concept. Energy is what an object needs in order to do work. Work is defined as really the actions that an object has. So, a chemical reaction is work, and it takes chemical energy in order to work, okay? Your car, when it moves, that is work. It takes energy to make it move. So, energy and work. The two types of energy we had mostly discussed were that of potential energy, which is stored energy, so the energy an object has before it does something. And the other type of energy is kinetic energy, which is the energy that something has when it is doing a thing, right? It's doing work. It's moving or it's combusting, something along those lines. Now, we did have two different types of potential energy. One was chemical potential energy, and the other was gravitational potential energy. As a refresher, chemical potential energy is going to be the energy that two substances have prior to a reaction, okay? It's the energy that's stored in the bonds prior to them breaking in a chemical reaction. So like baking soda and vinegar, before they are mixed, they have chemical potential energy, and when you mix them, they react, and the reaction is thus the kinetic energy. The other is gravitational potential energy, which is the energy something gets as it gets higher off the ground. So the further off the ground it gets, the more potential energy it's getting. The closer it gets to the ground, the less potential energy it's going to have. Now, potential energy can be transformed into kinetic energy, and kinetic energy can be transformed into potential energy, right? It can also be transferred from one object to the other. So we're going to use the example of a pendulum, okay? A pendulum is this because it's the easiest way to show energy transformation, right? So before the pendulum starts moving, it has potential energy. And as it starts to move, it's going to be transforming that potential energy into kinetic energy. And when it reaches the bottom, it's going the fastest, and it's going to go back up the other side. So now it is transforming its kinetic energy into potential energy, right? So pendulums are a great way to show a transformation between potential and kinetic energy. Similarly, this energy can be transferred from one object to another. So I'm going to adjust this here so we can see my table. I have an empty box here, okay? It is completely stationary, right? So it doesn't have any kinetic energy, it just has potential energy. It's waiting, okay, for something to make it move. And that kind of gets to Newton's first law of inertia. An object at rest is going to stay at rest until something makes it move, okay? That unbalanced force comes and forces us to move. But until then, it's at rest, okay? Now, my pendulum, okay, when it's hanging there, it's at total rest, all right? Now, I'm going to be that unbalanced force that pulls it upright. So gravity is going to be the unbalanced force that makes this move when I let go. Right now, it has maximum potential energy. It has the potential to move. Once I let it go, that potential energy is going to transform into kinetic energy, and then it's going to transfer to the box. So the box moved because it got the energy from the pendulum, which got its energy from its height, okay? So, quick recap. Transformation occurs when the pendulum is moving. So it's going from potential energy to kinetic energy. So anytime we have a change in the two energies, we are transforming it into something else. When the pendulum hit the box, this would be our energy transfer. The energy transferred from our pendulum to the box and caused the box to move. the box itself also has a transformation because it went from having potential energy, not moving, to moving, and when it was moving, it had kinetic energy. So, energy transfer, energy transformation, that's the short. Thanks.